Just share your screen.
Yeah, you should be able to share yours.
Yeah, I think that's
perfect.
Okay, great.
Yep.
Yeah. So yeah, hi. Thank you very much. Yeah, in the first maybe yeah. So the title was Auditor and Dalek, but you know, a few days ago I've started to making some models and interactive applications. So I decided to just focus on the explanation machine learning because I want to show you much more than I wanted in the beginning. So okay, so today I will talk only about the Dalek, the tool for explaining machine learning models. If you're not really familiar with machine learning, that's okay, because I will do some basic introduction, and I hope yeah, I won't lose you. But if you got any questions, just let me know, and that would be great if you have any questions. Okay, so first of all, yeah, I'm Alicja Gosiewska. You can call me Alicja or Alicia or Alice, as you want and as you can pronounce it. Yeah, I came from Poland, from Warsaw University of Technology, where I'm doing a PhD in computer science, and I'm visiting Davis for 2 months. Yeah, because I'm doing some project with neural network in proteins. Okay, and yeah, here is a link to the GitHub repository. So you can go to this repository, and there you will find my today's presentation, PDF with my presentation. Also R codes of the plots and other stuff that I will be showing you today. And also a link to the interactive application that I will show you in the end, but yeah, you can try it out even right now. But I will explain during the presentation what's going on in this application. Okay. So, sorry. Okay. Yeah. So, okay, I am also leading an R group in Warsaw. So if you're going visiting Poland someday, so just reach me out and visit our group, or even tell about your stuff there, because we're really open to hear what other people are doing. Okay, so first thing, machine learning. Okay, so I've got a question. Who do some machine learning stuff, like at least linear models or something like this in your work? A little bit, but not everyone. Okay, well, that's great. So, but probably even if you're not doing machine learning at all in your everyday work, you heard about some machine learning stuff. Like, for example, DeepMind, it's a really big company it's inside a part of Google right now, I think. Yeah, they've trained the neural networks to play StarCraft 2, yeah, like a computer game. Yeah, and they've got quite a good results because they were beating a lot of players, most players, even top players, yeah, top players. Yeah, so, and behind this is machine learning, like neural networks. Another success is, again, DeepMind, it's AlphaFold. It's something close to thing I'm doing here, because it was using a machine learning for predicting 3D structure of proteins. Okay, and that's really important because that helps to create new drugs, for example, or cure diseases. And yeah, as every year, the increase in this field is something like this. So last year, with the machine learning from AlphaFold, the increase of the knowledge in the domain was something like this. Yeah. So yeah, people have seen that machine learning might be used also in this field, and there are a lot of different areas when we can use machine learning. Yeah. For example, self-driving cars. Behind them, there are also machine learning algorithms. Yeah. And think about anything that is related to the technology, and probably there is some machine learning stuff inside and behind them. Okay, so we are using machine learning in our everyday life. Sometimes we don't even know that we are using machine learning, but yeah, and some introduction how to think about machine learning model. And for the purpose of our today's presentation, that might be enough to think about machine learning algorithm as a black box. Okay, so we've got a box, we input something to the box. I will call those inputs like variables or features. And then we've got output from the box. We don't know what's inside. So we can put some information about the customer, and we've got output with the information whether should we extend or deny credit. Okay, or we can put into another black box, we can put information about an apartment, and then we got a prediction of the expected price of this apartment. Yeah, so we can put that the number of rooms, the floor, the city, the part of the city where the apartment is, the surface, and we've got the prediction of the price of this model of this apartment. Yeah, so there are a lot of different applications, but think about the machine learning model as a black box. Okay, you don't have to know what's inside, and usually even people that are doing machine learning stuff don't know exactly what's inside them, because neural networks have thousands of even hundreds of thousands of coefficients. So for human brain, it's hard to go through the whole network and know what's going inside. Yeah, it's like trying to understand a brain. Okay? Neural networks are less complex, but it's hard to understand what's going on inside the brain. Okay. Yeah, and there is this problem. Like for many machine learning applications, we are using machine learning, but at the same time, we do not exactly know what's going inside the machine learning algorithms. Like, yeah, and 10 days ago, there was a huge thing with Apple. Like, it appeared that algorithms that were choosing the limit on the Apple Card were providing higher limits for men and lower for women. Yeah, and for women, and that was a huge thing because those algorithms, we cannot talk with them like why I got lower limit on the card. Yeah, we got just only a response like this is your limit, and we do not know what exactly happened, why I've got lower limit than other person. Okay, and another thing, it's even more important. I don't know, maybe you heard about this, a compass. It's a system that was using by US courts to assess the risk of the recidivism. Yeah, and when you look at those examples, we've got two people here, and if we look at their offenses and the predictions of the model, you can clearly see that is something wrong. Yeah, so there was a bias, race bias, there was a gender bias in this system. This system had a lot of issues. Yeah, I think it's not using right now, but yeah, but there were a lot of problems, and the decision it was making were really important. Yeah, because the decision might affect whether we stay in jail or we go out from jail. So it is really important to know what drives the predictions of the model. Yeah, and now the governments are really interested in this because the last year or 2 years ago, the European Union provided right to explanation. It's like the law that if machine learning algorithm made a decision that affects someone's life, this person can ask about the factors that drive of the prediction. Yeah, like why didn't I receive a loan, a credit? Okay, and everyone now have right to ask why, and yeah, and people that who are doing machine learning should now explain why the algorithm work in this or in the other way. And also DARPA see a need for explainable artificial intelligence, like explaining machine learning. So there are a lot of different projects and a lot of funding for developing new ideas to explain machine learning models. Okay, so that was some introduction why this area is really important. And it's quite a new thing because first, paper that was related to XAI and was quite a breakout. Was in 2016, so 3 years ago. And yeah, since then the area is developing quite fast, and actually every week there are new papers, new methods to explain machine learning models. Yeah, and today I will show you how to do it in R, and yeah, how to explain machine learning with R packages. Okay, so first of all, we need to create some examples. So we'll start with machine learning model. So I've chosen FIFA 2019 dataset. It is a dataset with information about players, soccer players, different players. And for each player, we've got, for example, his value, like what would be the cost of buying such a player, and also other informations like age, like score of dribbling. You can see, I've got here part of the data set. Yeah, so we can see that there is dribbling, volleys, short passing, preferred food, and so other stuff. Yeah, and we will try to yeah, and on the bottom there is a code that creates gradient boosting machines. It's a machine learning model. You can think about it as a black box because we don't care what's inside, what's the kind of model. But we have to know that this model takes information about a player and predicts the value of this player. Okay, great. So now we've got model, and how are we going to explain its predictions? Because right now we've got just model, just a black box. We put in data about player, and we got the predicted value of this player. And what we can do more is try to explain what are the reasons that the value of this player is this or another. Okay, so on this graph we are here. So by creating a model, with this DALEX framework, we can create model in R. We can create model in R with Caret or MLR. We can also create Python models or H2O models. That each kind of model is okay. Then we have to wrap up this model in a unified way with the DALEX. I will show this in a minute, how to do it. And once we've created that unified object, we can use other packages to explain the model and explain different models in the same way. Okay, so let's see how to do it. We've got our model that we've created, FIFA GBM, and then we just have to use explain function to provide a model and wrap up it with the metadata that was used for training. So the data said that the model was trained on the true values of the players, and also if the model is not so common, we also might have to provide a predict function. Also, predict function is a function that we use to know what would be the prediction of the model for this player. So it's a function that we provide model, we provide the player, and got the result, like the predicted estimated value of this player. Okay, so with this we're ready to create some explanations. Yeah, so let's see what our model will tell us about this data set, these players. What is important to the value of a player? Okay, so now what we can see here, we can see importance of the variables. Okay, it is really great because those importances do not depend on the model. Like some models have classes of models have their own ways to calculate importances. Yeah, but this importance do not depend on the structure of the model. Yeah, so the longer is the bar, the more important feature is. Yeah, so you can see that reactions are really important to the value. So probably the better scoring the reaction, the higher value of the player. The same for ball control and age. Okay? And how do we know that, for example, the age is important? So we can calculate the performance of the model. By performance, I mean how good it predicts the true value. So we can, for example, look for the differences between true values and values predicted by a model. Yeah, and the higher are the differences, the worse is our model, right? The best model would have 0, differences equals 0. Yeah, so how do we calculate this importance? So we predict we calculate performance of the model on our data set. Then we would like to somehow blind our model into the variable. So we can permute the values. For example, we permute the values of the age. So we blind our model of these values, yeah, like hide the effect of age. And then again, look at the performance of the model. If the performance is really, really low, when compared to the original prediction, that means this variable, this feature age was important, yeah, because performance of our model really decreased. Yeah, so we can see that in a global way, like in a global explanation, is that those 3 variables are really important. We would like to also know what is the dependency of the age, like are older players more are more valuable, like they are more experienced, or maybe younger because they are younger and maybe they are in better condition. So we can calculate also partial dependency plot. It's one-dimensional look at the dependency between variable, in this case age is on the x-axis, and the average prediction of our model. Yeah, so for players who are at age 30, we can see that the average prediction for their value is a little above 2 million euro. Okay, so we can see that with if the age increases, the value of our players decreases, right? Okay, so we can have some insights into overall model, but the most interesting thing is looking at our players, like an instance way of our models. Because, okay, in the end, we've got 2 players. Wojciech Szczęsny, he's a goalkeeper from Poland, and Cristiano Ronaldo, yeah, he's a player from Portugal. Yeah, and our model predicted some values for those two players, 2 guys. Okay. And okay, we can say, hey, Cristiano Ronaldo is better, his value is really higher, but we would like to know why. Right? Like the same example, I didn't get credit and why. Yeah, I want to know what was the reason. Maybe Wojciech Szczęsny might do something to increase his value, and he would like to know what should he do. Yeah, so there are some ways to explain particular instances, particular players, like, for example, breakdown plots. And breakdown is the explanation of the prediction by dividing it into contributions of each of different variables. Okay, so what can we see here? It's a breakdown for Cristiano Ronaldo. Yeah, so we're explaining only why Cristiano Ronaldo has such a high prediction of his value. Okay, so let's go from the bottom. The bottom bar is the prediction. The left side is the mean prediction. So the mean player would have a prediction about $10 million. Okay, and Cristiano Ronaldo prediction is 78 millions. Yeah? Okay, and now we would like to know which variables were such important for him that the prediction of his value was so high. So you can see that reactions equals 96 increased his value because it's quite a high score. Also about ball control increased his value a little bit. Finishing, dribbling, but his age, 33, decreased his value. Yeah, so as we've seen, that older player have lower value. Yeah, so yeah, as for a player, he's quite old, so it decreased his value, but all other things increased his predictions. Yeah, and we can also look at szczęsny. Yeah, so as a goalkeeper, other features were more important for him, like goalkeeper diving or goalkeeper reflexes, also reactions. Yeah, but yeah, he's also quite old as a football player. Yeah, and he don't have so good ball control, so he's also decreased his predictions. Okay, great. So now we would like to maybe we would like to ask, okay, so Cristiano Ronaldo is a great player, but his age is decreases his predictions. So what would happen if Cristiano Ronaldo was younger? Like for example, what if he's 20? So we can also look at this. Going back to our credit scoring example, because he can get become younger, right? But with, for example, this credit scoring, we can see what can we do to increase our chances. Like what would be my chance to get a credit if I had, if I was earning $10,000 more, or something like this. Yeah, so those are some what if reasonings. Okay, so our Cristiano Ronaldo is somewhere here. So yeah, if he would be younger, his value would be higher, yeah, due to our model. Yeah, and that's a different thing that I showed you in the beginning, because previously it was expected value over all players, like these PDP curves, but now we look only on the Cristiano Ronaldo. So we have fixed all other variables on the values that Cristiano Ronaldo have, and we just move the age. So we can we see the prediction of the model only by changing the age of Cristiano Ronaldo. It's only for Cristiano Ronaldo. Yeah. Okay, great. And I think the most exciting thing about this is that we of course can plot things in R, like changing the values and other things, but with R we can, because you've seen the code, right? But with R we can also create great applications like this model studio that we are developing. That's one of the things that we're developing in Warsaw. Yeah, so we can just try it out by your own to try explain some predictions. Yeah, so we can choose a player. So would you like to see some player? Yeah, Messi, Lewandowski, Ronaldo. You can choose. Neymar. Okay. So Neymar, and then we can try to plot some explanations. So let's start with this breakdown I've showed you at the beginning. And can you see it, or should I maybe? Okay, so wow, he's the best. yeah, we can look on the value that increases finishing. If you don't know how to read the plot, you can also look at the description, for example, yeah, and to see how to read this plot. We can try to add ceteris paribus. So what would be his value if he was younger? Yeah, we can by clicking on the variables, we can look at the other ones, yeah, and also things like this. Yeah, and of course there are a lot of other explanations like sharp values. That means the local importance of the variables. Yeah, I showed you the global for the whole model, but we can also calculate importance for a particular player. Yeah, with this sharp method. Yeah, and also other things. Okay, so I think it's all that I want to show you today, just to just to inspire you to not only using machine learning models if you're using them. If you're not using, try, because it's quite fun. But then I think that the most exciting thing is explore the model and see what dependencies it found. Yeah, and yeah. Okay, so thank you very much.
So folks have questions?
Yeah.
You can go ahead and do that. I have a question. So what did you do to code the interactive? Is that a Shiny or something?
No, it's D3 in JavaScript.
JavaScript, okay.
Yeah, JavaScript. Because Shiny is too slow to think
That's
like
well,
this.
that's what I was asking, because it
Yeah.
just seems much cleaner.
Yeah, and yeah, the great thing is that you just get an HTML and you can share it. You don't have to start a server or something like this.
Yeah, nice.
Yeah, that's why there is a link, just HTML in the repo.
Yeah. Do you use this with other? So I use boosted regression tree models a lot, so this is awesome. But do you sort of use other? Is this sort of framework flexible with other, say, like more commonly used now Bayesian frameworks or random forest or similar?
Yes, of course. The only thing is that you need a model that takes observations and returns some values that might be classification or regression. Mm-hmm. Yeah, and it will be working with anything. Yeah.
Are there limits on sort of the sizes or complexity of models that will still work in this sort of process, right? You know, because maybe under some circumstances, the model takes forever to fit, or
yeah. So yeah. So here So here you're using trained model. Yeah. So the training is previous step. The one thing that might be difficult is the time of the prediction. Like for random forest, it takes years sometimes for big data sets. Like So the only thing is that there is a lot of predictions of different versions of the data set. So that might be a little slow. But for models that can predict really fast, it's not so. Yeah, it's not a problem.
Are there also opportunities to explore potential interactions? Because when you showed me the plots of Ronaldo and Chesney, I think clearly age matters, but I suspect being an older goalkeeper is less of a problem than being an older striker. So are there ways to perhaps, or planned ways to perhaps plot sort of multiple, to figure out this interaction covariance, right? That maybe age effect is going to depend on what position you have as well, something like that.
Okay, so actually we've implemented, for example, the version of the breakdown that also includes the interactions that identify them. I think it's not already here, but probably it will be. So there are methods that look at the interactions by themselves. But I think it's a great question, because people usually explain the things like in additive way, and they do not care about the interactions. So there will be an opportunity, but right now probably not. Yeah.
Awesome. Well, thank you for
coming and blowing
our minds.